Okay, let's describe the right hand, left hand behaviors and state the maximum number of turns. So let's say what's going on with the left side of the graph, with the right side of the graph, and let's state the maximum number of turns. Okay, so I'm going to go write this for all of these. Actually, I'm going to kind of abbreviate. Let's say what's going on the left, the right, and max turns. Go ahead and write this for all of these. Left, right, and max turns. Okay, we're going to figure out what's going on the left and the right side of the graph, and then the maximum turns. And remember that the maximum turns, we just talked about that, it is the degree minus 1. So what I like to do when I'm working on these problems is I like for you to go through here and tell me, for each of these, is this an odd or even degree? And is it a positive or negative coefficient? And especially until you get the hang of it, I think it helps. Well, this is an x to the third. This is the highest degree, so this is an odd degree. And 1/4 is the leading coefficient, and that is a positive number. So this is an odd positive. Odd tells me the graphs, the ends of the graph are going to go in different directions. Think about a line with a positive slope. If you need to flip back over at your notes, you can do that at the little box we just did. But try not to do that. Think about a line with a positive slope. What does the left side of the graph do? It goes down. What does the right side of the graph do? It goes up. And what's the maximum number of turns? Well, this is a third degree graph, so 3 minus 1 would be 2. That means this third degree polynomial will only turn 2 times. So that's the maximum number of times it could turn. It may not turn that many times, but that's the maximum number of times it could turn. And just to give you a visual, here's what the graph of that would look like, something similar to that. Left side is down, the right side is up, and it does turn 2 times. So that's just a visual of what the graph looks like. Alrighty, number 4. Odd or even, it's a 5th degree. That is an odd degree. Okay, look at this leading coefficient. Is that a positive or negative number? It is negative 3.6, so it's negative. This is an odd negative. Odd, going in different directions. One side is up, one side is down. Okay, think about a line with a negative slope. Negative slope. So the left side is up, right side is down. Okay, maximum number of turns. This is a 5th degree. 5. 5 minus 1 is 4. So it has a maximum number of 4 turns. Alright, just to give you a visual of the graph, not perfect, but it looks something kind of like that. Okay, something similar to that. So 1, 2, 3, 4 turns. 1, 2, 3, 4 turns. Okay, one more of these guys, and then we'll try something a little bit different. X to the 4th, so that is an even degree. Leading coefficient here is an invisible 1. It is a positive number. So this is an even positive. Alright, even degree graphs go in the same direction. Since it's positive, that means they're both going to go up. Both up. Maximum turns. 4th degree minus 1 would be 3. Again, let me show you what the graph looks like. Just kind of a rough sketch of it. Something like that. Both ends are going up, and it turned 1, 2, 3 times. So there's how you describe the ends of the graph, the left and the right, and give the maximum number of turns. So now for our final 3 examples, we're going to take all this information and kind of put it all together, taking some stuff that we did last year from Algebra 2. Well, we actually did some of these in Algebra 2 last year, so hopefully this will just be a review for you. Okay, so on number 6, we're going to find all the real zeros of f of x equals negative 2x to the fourth plus 2x squared. And we've had several problems so far. Whoops, there we go again. Won't let go. Hold on. Okay. We've had several problems where we found the zeros, and we've had to do this by factoring. And after we find the zeros, even though it doesn't say to graph this, since we've been working on finding the ends of the graph, I'm going to sketch a rough sketch for you using kind of what we've talked about today so you can get the big picture. So we're going to find the zeros, and I see here that I have a common factor of negative 2, and they also have x squared in common. So I'm going to factor out a negative 2x squared to start off with. If I factor a negative 2x squared out of this, I have x squared left. If I take a negative 2x squared out of this, I have negative 1 left. So I have negative 2x squared. This can factor again. This is still the difference of squares, so this factors into x plus 1 and x minus 1. Okay, so I have 3 factors, so from there I'm going to get 3 zeros. So from here I'm going to get the 0 of 0, because if I set negative 2x squared equals 0, I'm going to get 0. From here I'm going to get negative 1, and from here I'm going to get positive 1. Okay, so these are my 3 zeros. Now, this is all I'm asked to find, but I know what you're going to have to do in the next section as far as graphing goes, and we're going to go ahead and talk about this now, and it's going to make it a whole lot easier for you later, because you need to be able to graph these coming up. Alright, look at this box. It's kind of down on the bottom right of your paper, but I put it up here on my notes. Odd degree factors, okay? These are your factors right here. These are your factors. These are your zeros. Odd degree factors cross the x-axis at the zeros. Even degree, odd, even degree factors touch the x-axis at the zeros. Alright, let's talk about this. Odd degree factors. Well, this was x minus 1 to the invisible first power. This was x plus 1 to the invisible first power. This was negative 2x to the second power squared. Okay, so look at the degrees of your factors, okay, of your factors. Because that's going to tell you something about these zeros as where your graph is, whether it's going to actually cross at the x-axis or whether it's just going to touch at the x-axis. So I want us to write those underneath our zeros, and then when I show you on the graph, I think it'll make more sense. Okay, this was negative 2x squared. Squared 2 is an even degree factor. So that means my graph is going to touch the x-axis at this 0. So at 0, my graph is only going to touch at 0. Okay? Now, x plus 1 was a first degree factor, and x minus 1 was a first degree factor. Those were odd degree factors. So at negative 1 and 1, my graph is going to actually cross through at those numbers. Alright, let's take a look at the graph, and you'll see what I'm talking about. Okay, now let's talk about, or let's think about the end behaviors of the graph. Okay, we just got through doing that. This is an even degree with a negative coefficient. So that means the ends of my graph, both of them are going to go down. Okay, left side is down and the right side is down. Well, these are my 3 zeros at 0, negative 1, and positive 1. Right, negative 1 and positive 1. Now, based on the fact that I should cross the graph at negative 1, okay, I should I'm going to put a little C here. I should cross at -1 and I should cross at +1, but I should only touch at 0. Let's take a look at what this should look like. My graph should start down here. Oops, that's not very straight. Should start down here. Let me erase that. Uh-oh. Can I undo that? Yes, okay. Okay. Alright, here we go. Start down here. It's going to cross through. At some point in time up here, it's going to have to curve around, come back down, hit this, and look, we're just going to touch at 0. We need to touch it, curve around, come back up. Some point in time, curve around. I didn't make me enough room here. Touch the 1, cross it, and come back through. Alright, I'm going to kind of draw it a little bit better. Your graph should look, it's one of these. Okay, where you cross at -1, you touch at 0, and you cross at +1. Okay, we know it's even negative. We know both ends are pointing down. We know it's going to cross at these two numbers, and we're going to touch at 0 based on the degrees of our factors. So, even though all we were asked to find here was the zeros, I know where we're headed, and you know now where we're headed as far as having to graph these. So we're going to go ahead and think about and kind of rough sketch what our graph is going to look like now, because we're going to have to do this soon anyway. Okay, so let's go ahead and move on to number 7 and see if we can do the same thing for that one.